Okay, good day, my fellow learners. Welcome to the channel. Don't forget to subscribe. Today, we are going to do the nature of roots. Nature of roots. We are going to do the nature of roots. By definition, the nature of roots simply states they describe the type of numbers, the roots are. This is a simple definition of what of nature of roots. They describe the types of numbers the roots are. Don't be confused by the weight or the term root. It simply implies the x-intercept of any quadratic formula. The word root, it implies the x-intercept of any given quadratic formula. Then now, for us to determine the nature of roots, we must firstly know on how to use the discriminant. For us to determine the nature of roots, we are going to use what? The discriminant. The discriminant is as follows. Delta is equals to b squared minus 4ac. This is the discriminant of any given quadratic formula. Bear in mind that the quadratic formula is in a form of y is equals to a x squared plus bx plus c. This is our quadratic formula or the parabola formula. The parabola formula or the quadratic formula. Then this one is going to represent the discriminant for us to determine what the nature of roots. Do you understand, my fellow learners? Then now, listen. There are certain types of condition that the learner must know in order for him to determine what the nature of roots. Those conditions are as follows. And bear in mind, don't forget, my fellow learners, that this formula, you see this formula? This formula is for your discriminant. Just next to this formula, we have what? The quadratic formula. Then for us to move forward, a learner must be able to know the certain types of what? Of conditions for him or she to determine the nature of roots. Those conditions are as follows. We are going to start by saying delta or the discriminant of any given quadratic formula. The very same condition, it splits into two, or it is divided into two components. The first component, it is whereby your discriminant is less than 0. We say whenever your discriminant or the value of your discriminant is less than 0, that means when it's negative, then it's going to be a non-real or imaginary or non-real root. Do you understand, my fellow learners? Let us keep moving. Then now, this is the first condition that we are going to get whenever your delta or your discriminant is less than what? Less than 0. Then now, listen. Another condition is whereby your discriminant is greater equals than 0. Whenever your discriminant is greater equals to 0, let's say from 0, 1, 2, 3, then you continue that way. On that note, we say our discriminant is real roots, such they are going to represent the real what? The real roots. As for this one, we said they are non-real because they are less than 0, which means they are negative. For this ones from 0, continue onwards towards infinity, we say such are what are real roots. They further branch into two. The real roots, they branch into two. Firstly, we are going to have a condition whereby your delta is greater than 0, and also whereby your delta is equals to 0. Then, for this first condition, we are going to say such roots, there are two of them. There are two of them. We say they are unequal. Two unequal what? Unequal roots. Two unequal roots. But for this one, we are going to say they are two equal roots. You must know these conditions, my fellow learners. You must know these conditions. Furthermore, these ones whereby your delta is greater than 0, it further branches into two, again into two, whereby your delta is equals to a perfect square, a perfect square. For an example, like 4, 16, such numbers, we say they are perfect square. Then the first case is whereby your delta is a perfect square. We are going to say such roots, they are rational. Such roots, they are rational. But whenever we get any number which is not a perfect square on this note, is not a perfect square, then we say such roots, they are irrational. They are irrational. An example of a perfect square is like 4, 16. You get a point? 4, 16. Then of irrational numbers like 2, 3, which are not perfect square. It's more like a perfect square is more like a square of a number. 2 squared is equals to 4. 3 squared is equals to 9. Square of a number, we say those are the perfect square. Do you get the point? Let us go back a little bit. We said the nature of root describes what types of numbers the roots are. The roots are. Then the word root simply implies what x-intercept of any given what quadratic equation. For us to determine the nature of roots, we are going to use what this formula is for the discriminant. This is just what the quadratic formula. The reason that I wrote this one, I wanted you to be able to see the values of b. Where do we get the value of b? For an example, the value of b is going to be any number which is next to what? To x. Then for this one, for a, the value of a will be any number that is next to x squared, which is a. Then for c, it's just that number there. We said that number is called what? A constant number. Then now I'm going to give you let us take one example and see how to determine the nature of root whenever we are given such example. Okay. Our first example for today is this one. Then the question states, determine what? The nature of roots. The nature of roots. For us to determine the nature of root, the first thing that we must do is to determine the discriminant. From there, we are going to choose the correct what condition that correspond with that value of the discriminant we are going to receive right now. Listen, my fellow learners. Firstly, we are going to write the discriminant formula. The discriminant formula is as follows. Delta is equals to b squared minus 4ac. Do you get the point? Do you get the point? Do you get the point? Then from here, we must identify the values of a, b, c from our quadratic formula. Do you understand? From our quadratic formula, bear in mind that our general quadratic formula was as follows: a is equals to a x squared plus bx plus c. In this case, our a is going to be any number which is next to x squared. We say such it's a coefficient. The coefficient of x squared in this format is going to be 1. To get that, then let us move to b. Our b is going to be negative 2. So simple, isn't it? Then our c is going to be correct, negative 1. Those are the values. Then from here, we are going to take these values and substitute where on our discriminant formula. Then we are going to substitute these values. Firstly, we are going to start with b, which is negative 2 squared, our 4, then a, 1, c, negative 1. Then from here, you can just use your calculator to make sure that you get the correct answer. Let us use our calculators, my fellow learners. Then for this one, you are going to get 4, then negative 4, then positive 1 multiplied by negative 1, we are going to get negative 1. Then negative multiplies by negative, you get a positive, which is 4 plus 4. Then your final answer is going to be 8. Do you get this? Do you get this, my fellow learners? Then from here, we are not done. This value 8, it represents our discriminant. Then we are going to use those conditions we spoke about earlier in order for us to determine the nature of roots. At this point, we haven't yet answered what the question. You understand, my fellow learners? At this point, we haven't yet answered our questions. Then listen. Now it's so simple. We said we have the following into conditions. We said we have the following into cases or conditions whereby our delta is less than 0. Such roots, we say they are non-real. 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 Is 8 less than 0? Is 8 less than 0? Definitely not. Then we are going to cut this one out. Do you understand, my fellow learners? Then obviously, if it's not less than 0, then it's going to be somewhere greater equals to 0, which represent real roots. Then the word real is going to be your first answer to this type of discriminant. Don't forget this. This discriminant, it further branches into 2. Do you still remember? This discriminant, it further branches into 2. The first one was greater than 0. Then the second one we said was equals to 0. Then we said this type of the discriminant, it represents the two unequal roots. Then we said this one, whenever the discriminant is equal to 0, such roots, they are equal. Then let us go back to our value of 8. Is 8 equals to 0? Definitely not. Then we are going to cut this one out. Then we are going to be left with discriminant which is greater than 0, not equals to 0. That means this 8, it will represent an unequal what? Unequal roads. And my fellow learners, don't forget that we said the very same discriminant of greater than 0, it further branches into 2. We said the first one is a perfect square. We said the first one is a perfect square. Then another one, it was not a perfect square. Underneath this one, we wrote what? Rational. Underneath this one, we wrote irrational. 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 Let us go back to that number. Is 8 a perfect square? Definitely not. Then we are going to cut this one out. Then we are going to be left with what? Irrational. You right? Irrational. Do you get the point? This is how we are going to answer this question, which says determine the nature of root of this given equation. Firstly, you start with your discriminant. After getting your discriminant, you are then going to go to your conditions and try to figure out which suitable condition must you write